Walking for 30 minutes doesn't make you lose weight. It makes your fat cells change their behavior. If you think fat is just something sitting quietly under your skin, waiting for you to burn it off, then you're misunderstanding your own biology. Beneath your skin and around your internal organs, there are roughly 30 to 40 billion fat cells. 30 billion. And they are not passive at all. They are genuine endocrine organs. That means they secrete hormones, they communicate with the brain. They respond to insulin, adrenaline, cortisol. They read signals from your nervous system every minute. Each fat cell is like a tightly secured energy warehouse. Inside are triglycerides, 3 fatty acid molecules locked together. These molecules cannot simply walk out on their own. To release them, the body must activate a chain of enzymes. The right hormones must be present. The internal environment must be right. And here's what most people are never told. Fat cells are not the enemy. They are a protective force. When you eat more than you need, they absorb the excess energy and lock it away, so that fat doesn't float freely in your bloodstream and become toxic to your liver, heart, or pancreas. That's a survival protection mechanism. The problem isn't that you have fat. The problem is the signals your body is receiving every day. When fat cells become overstretched, when they constantly receive the signal to store, they begin sending signals back in the form of inflammatory molecules. That's when insulin resistance appears. Visceral fat increases, and metabolism becomes disrupted. Not because fat is evil, but because the signaling system has been distorted for too long. Now imagine this. You stand up. You start walking. In the first few minutes, your body hasn't touched your fat yet, but your sympathetic nervous system starts to activate. Your heart rate rises. Blood flow increases. Adrenaline begins circulating in your bloodstream. And when adrenaline reaches the surface of a fat cell, it's like a key sliding into a lock. It activates an enzyme called hormone-sensitive lipase. This is the enzyme responsible for breaking down triglycerides, the first step of lipolysis, meaning fat breakdown. This doesn't happen after a month, not after 3 weeks. It begins within minutes. At the same time, insulin in your blood begins to drop slightly because your muscles are using glucose. And low insulin is the second signal telling fat cells, you can open the warehouse. 2 signals. One from the nervous system. One from hormones. Both coming from a very simple action: you are moving. Many people ask me, is walking powerful enough to burn fat? That question misses the point. The right question is walking powerful enough to change biological signals? The answer is yes. And precisely because the intensity is moderate, it is optimal for fat. When you run too fast, your body shifts to prioritizing glucose. When you train too hard, cortisol can rise too high, and the body defends itself by conserving energy but brisk walking at a pace where you can still hold a conversation, breathing a bit deeper than usual. That's the zone where fat oxidation reaches peak efficiency. Around 45 to 65% of maximal oxygen uptake. This is not a weight loss trick. This is biological language. I want you to look at something again. You are not lacking willpower. You may be sending the wrong signals. If you sit all day, eat, stay stressed, and sleep late, your system receives one message: hold on, defend, store. But when you walk consistently every day, even just 30 minutes, your body receives a different message. We are moving. Energy will be used. No need to panic. Fat cells respond to that message. They become more sensitive to lipolysis. Blood flow to adipose tissue increases. Fat-breaking enzymes work more efficiently. And most importantly, they relearn how to switch between storage and release. What science calls metabolic flexibility. What I always emphasize to my patients isn't the number of calories you burn in 30 minutes. That number is relatively small. What matters is that you are reprogramming how your energy system operates. Part 1. The 30-minute timeline. When the body shifts from sugar to fat now, we put emotion aside. Just biology, just mechanism. 30 minutes of walking is not one continuous block. It is a sequence of energy transitions in stages. And if you understand exactly what happens minute by minute, you will never underestimate a walk again. 0 to 5 minutes. The nervous system gives the order. In the first few minutes, the body does not prioritize fat. The main fuel at this stage is glucose in the blood and glycogen stored in muscle and liver. That is completely logical. The body always uses the most accessible source first. But what matters is not the fuel being burned, it is the signal being sent. Heart rate rises. The sympathetic nervous system activates. Adrenaline and noradrenaline are released. These two hormones bind to receptors on the surface of fat cells and activate hormone-sensitive lipase, the enzyme that unlocks triglycerides. At the same time, insulin begins to drop slightly because muscles are pulling glucose out of the bloodstream. Low insulin is the permission to release signal. When insulin is high, fat cells hold tight. When insulin falls, the door begins to open. Within the first 5 minutes, lipolysis has already started. But it has not reached a high rate. You are not yet burning fat hard, but you have flipped the switch. And this is the point many people misunderstand if you stop at minute 5. You have only switched on the system, not entered the real metabolic zone. 5 to 15 minutes. Fat begins to leave the warehouse. Around minute 10, lipolysis increases noticeably. Triglycerides in fat cells are split into free fatty acids and glycerol. The fatty acids enter the bloodstream. Blood flow to adipose tissue increases, allowing them to be transported to muscle. At this stage, muscle begins to change its fuel preference. Instead of relying entirely on glucose, it starts moving fatty acids into the mitochondria, the cell's energy factories, to undergo beta oxidation. Beta oxidation is the process of converting fatty acids into acetyl-CoA, which then enters the Krebs cycle to produce ATP. This is energy production from fat. Not an illusion, not a marketing concept, pure biochemistry. The proportion of fat oxidation begins to rise. Glucose is still being used, but fat is gradually taking over. And here lies the dangerous boundary. Many people stop at minute 12. They feel that's enough. But in reality, they have just crossed the transition phase and have not yet reached the optimal point. 15 to 30 minutes. The optimal metabolic zone. From minute 15 onward, if you walk at a moderate intensity, fast enough that your breathing is deeper, but you can still hold a conversation, the body enters its highest fat oxidation zone. Physiological research shows that at around 45 to 65% of maximal oxygen uptake, the proportion of energy coming from fat can reach 50 to 60%. The reason is simple. Moderate intensity optimizes all 4 key processes of fat metabolism at the same time. First, the breakdown of triglycerides in fat cells. Second, the transport of fatty acids from blood into muscle. Third, mobilization of intramuscular fat. Fourth, delivery of fatty acids into the mitochondria. If intensity is too high, the body shifts to prioritizing glucose because it needs energy quickly. If it is too low and too brief, the system is not stimulated enough to increase blood flow and enzyme activity. Brisk walking sits precisely in the middle. Not extreme, but accurate. At this stage, there is another factor rarely discussed: irisin. This is a myokine, a hormone released by muscle during movement. Irisin can promote browning, causing a portion of white fat to behave more like brown fat, the type that burns energy to produce heat. That means you are not only burning fat in the moment of walking, you are influencing how fat tissue functions even at rest. In addition, repeating the lipolysis signal daily increases the expression of fatty acid transport proteins, such as fat, CD36, and oxidative enzymes. Fat cells become more cooperative, not because you force them, but because you train the system. This is the core logic. It is not the highest intensity that wins. The right signal, repeated long enough, wins. 30 minutes is not a random number. It is long enough to move beyond the glucose-dominant phase and enter the fat-dominant phase, yet light enough to sustain daily. If you remember only one thing from this section, remember this. Minute 15 is when your body truly begins to believe you are serious about movement. And minute 30 is when the metabolic system begins to learn how to adapt. Part 2. After you stop, the body has not stopped. You think everything ends when you get home? Take off your shoes and sit down. No, biology does not switch off that quickly. After 30 minutes of walking, your body enters a state called EPOC, excess post-exercise oxygen consumption. Simply put, oxygen consumption remains higher than normal because the system is cleaning up and restoring energy balance. But the important thing is not the term. It is the fuel being used right after you finish walking. Muscle glycogen has slightly decreased. The body needs to restore those reserves. And to do that, it needs energy. Where does that energy come from? From circulating fatty acids. Lipolysis does not stop immediately. Many physiological studies show that the release of fatty acids can remain elevated for hours after a moderate intensity session. The body continues mobilizing fat to support glycogen resynthesis and cellular recovery. In other words, you have stopped moving your feet, but your fat cells are still working. This is the point where consistency outperforms extreme intensity. A sprint session may burn more calories in the moment, but it also makes the body rely heavily on glucose. Moderate walking, on the other hand, creates a fat-favored metabolic environment and maintains it even after you rest. Now we go deeper. When you repeat this cycle every day, 30 minutes, day after day, fat cells do not just release energy temporarily. They begin to adapt. Fat cell size gradually decreases as triglycerides are drawn down, and smaller fat cells are healthier fat cells. They secrete fewer inflammatory cytokines. They are more insulin sensitive. They produce more adiponectin, a hormone that improves insulin sensitivity and protects cardiovascular health. Visceral fat also responds strongly to consistent movement signals. Intervention studies lasting 12 weeks show that simply walking 30 to 40 minutes per day can significantly reduce visceral fat, increase HDL, and lower inflammatory markers, even without extreme calorie restriction. The key point here is your system learns a new pattern. Instead of continuous storage, it shifts to flexible circulation. This is what physiology calls metabolic flexibility, the ability to smoothly switch between using glucose and fat depending on context. A metabolically flexible person is not necessarily lean, but they are less insulin resistant, less chronically inflamed, and their energy system is more stable. And there is an interesting paradox. The more consistently you walk, the less you need dramatic fat-burning episodes. Because the system is stable, fat cells are no longer overstretched and sending distress signals. They simply do their job, store when needed, release when called upon. No war. No biological panic. Part 3. You don't need to defeat your body. You need to send the right signal. By this point, we have enough evidence to say something plainly. Fat does not make you fail. The signals repeated every day determine the direction of your metabolism. Fat cells were designed to protect you. When excess energy appears, they lock it away to prevent lipid toxicity. When insulin stays high, they hold tight. When stress is prolonged, they prioritize storage, not because they are working against you, but because the system is responding faithfully to the environment you create. Walking 30 minutes each day is not a weight loss workout. It is a clear biological message: energy will be used. The system can stay flexible. There is no need for extreme defense. When you send that message consistently, a chain of changes occurs. Fat cells shrink and become less inflammatory. Insulin works more efficiently. Mitochondria increase their activity. The ability to switch between burning glucose and burning fat becomes smoother. This is system redesign, not system punishment. A common mistake is assuming higher intensity must be better. But biology does not operate on emotional logic. If you create too much stress, cortisol rises, and the body may respond by conserving energy. If you fast extremely but do not move, the signal is still shortage. Defend. Moderate intensity walking. Long enough. Repeated daily. That is an asymmetric lever. Low effort. High systemic impact. And here is the most important point. The body does not need perfection. It needs rhythm. 30 minutes a day does not change you because of one session. It changes you because it resets your metabolic biological rhythm. When movement becomes the standard rather than the exception, fat cells no longer need to hold on for an emergency day. If you are waiting for motivation, you will miss it. If you are searching for a rapid method, you will be disappointed. But if you understand that you are adjusting signals at the cellular level, you will see those 30 minutes completely differently. This is not a promise of weight loss in 7 days. This is measurable physiology. If you want to continue understanding your body in this systemic way, no hype, no moralizing, no extremes. Follow this channel. In the next video, we will talk about a silent mistake that causes many people to walk and train consistently yet still not lose fat. How they eat in the first 30 minutes after finishing exercise. Understand the system correctly. And you no longer need to force yourself now. Instead of searching for another new trick, do the simplest thing: stand up, walk, send the right signal.